Hello, everyone. This is Tom. You can call me Yang also. I'm from the Fanku team. I'm the team leader of the Fanku team. And our project is called HODI, which means horse body. And this demo, we got 5 steps. The first is the team members and the project description, and then tech stack, key features, and the reference websites, and then demo to show you the basic features. And then we'll go next step to the pass it to the DevOps. So we got 6 developers and 5 DevOps, and the tutor is Harris, and the DevOps tutor is Olivia. We don't have the UI design, but we got Kitson to help give us a hand to do part of the design, UI design, who is also from JR Academy. And we got BA as Claire. So with 6 developer is Rebecca, Alex, Hao Yu, Erica, Zoe, Tyron. And the DevOps is the team leader is the Archer, Lawrence, Chen, Hugh, and Nai. For the last couple months, thanks for team members and tutors. They do a lot for this project. This picture is from the website, where I will show you later. So this project is to build a website in a market segment of horses to provide a platform for people to post their needs and get feedback. It's like a connection between client and traders. We use some a stack like this page is short. Front end we use React.js, Redux, and the style components, RTK, and the back end we use the Node.js Express. We use the RESTful APIs, JWT to the token and password. Database is MongoDB. The tool is Mongoose. We also use some libraries such as Joy, and the server is AWS. We use Jira to manage the progress of the project, and GitHub. We also use Google Shared Document and Discord and WeChat to communication to do the some paperwork. So we have finished some features in these pages, and still got some advanced feature will be done in the next month maybe. We can for now we can log in, log out, register, and post a task, and you can check the post in your profile, and you can edit your profile. In the future, maybe we could do some advanced features like live chat, online payment. The main reference website is Airtasker and HiPages. And the database is here. So now let me show you the basic features. This is our website, but that is not the latest one. We got some update. So I just show you here. This is our homepage. Banners, some information after this. the folder. So first thing first, I just show you the profile. So you can log out here, log in, sign up here. So your first name, last name. Log in here. I just got my so this one show the code. If the code is not right, you can't log in. It will go back to the home page. So I'm gonna enter again. So after logging, the navigation is different. So you can you got access to this part, which is post needs. You can post your tasker, post your needs here. Browse needs, you can browse the news needs here, and the other somebody else already put it here. And my needs will show you the the needs of yourself. So this home page and the post needs. For the profile, you can edit your name information here, like you want to change your personal your name, you can edit here. Everything is changed, and the skills, like I just in some. So here, so this one we could leave this for the map API. So we just leave this one. You also can upload the picture here. So we'll show you how it look like the downside. And we also got contact us. So it's our team member. And thank you again for our team members' effort this 2 months. So we also got account here, which is you can send the message by phone. This one is not done yet. We just got the front end done. So now let's go back to a home page and post the needs. So like you want somebody to do cleaning for you, or cleaning, just as location, date, budget. So we also do some validation here, like sorry, if you didn't understand anything, you will get error, or your budget is like a 0, you'll get error, something like that. Just enter 122 here and submit. Successful. After successful, could be you can look at the browse needs here. We just added, so you can search the details on this page, and the web map API. This one is we just added the map API in, so it's not finished yet. For now, you can check the position, but not the details. And also, you can check your posts over here. So this one is the which we just posted. So it's information you just ended in the post needs pages. Yeah, so that's all for our basic features, and we're gonna keep doing that and finish the advanced features. And thank you again for the team members, and hope they got better after the 3 months in JR Academy. And for now, I will pass it to the DevOps. Thank you, everyone.
Hi, everyone. My name is Archer from DevOps teams. Okay, let's have a look at our infrastructure. For the front end part, we choose Amazon CloudFront as CDN, Content Delivery Network, to serve static files hosted in an S3 bucket. This approach is beneficial, especially in scenarios of hosting static websites on S3, because we get to leverage the feature of caching at edge locations to serve our content faster to our users. The CloudFront acts as a proxy to our S3 bucket. Thus, we do not have to make our bucket public, ensuring better security of our files. And we can enforce the HTTPS connections by registering a domain name and generating a certificate using ACM. This makes the website trustworthy and secure for our users. This is how we do. Firstly, we have registered www.hody.com as our website name through AWS Route 53 service. Secondly, we have set up S3 bucket for static website hosting and uploading our static website to it. And thirdly, we have set up a CloudFront distribution and link it with a custom domain. And lastly, we have secured connections for SSL and the AWS Certificate Manager. For our backend part, we choose the AWS ECS Fargate because it allows us to focus on running our application without needing to provision, monitor, or manage the underlying compute infrastructure. The Docker container will be run in a Fargate task, as we don't want to manage the EC2 instance for that. And this task is executed in a private subnet, talking to the outside via the net gateway in the public subnet. The application load balance in the public subnet furnishes HTTP request to our task, and the response is coming via the net gateway. For the monitoring part, we choose the AWS CloudWatch and Grafana, and we integrate CloudWatch metrics with Grafana to set up dashboard for monitoring our AWS services. From the customer dashboard, we can visualize performance data, create alarms, and correlate data to understand and resolve the root cause of performance issues in our AWS resources. Okay, let's move on to the next page. In order to manage the entire life cycle of our project automatically, we choose infrastructure as code tools Terraform. Terraform replaces standard operating procedures and manual efforts required for IT resources management with lines of code. Instead of manually configuring cloud nodes or physical hardware, we use Terraform to automate the process infrastructure management through source code, which is beneficial for the speed, collaboration, error reduction, disaster recovery, as well as enhanced security. Okay, let's move on to the next slide. We also use Terraform modules to create lightweight abstractions, which making our code more simplified and available for the future reviews and revision. Okay, following my teammates, Lawrence, we will be covering the CI/CD pipeline and monitoring.
Thanks, Archer. Move to the next page, please. Yeah, in the CI/CD pipeline, when developers push the code into GitHub, Jenkins will be triggered to pull the code from GitHub to run the pipeline. The ability to pull code represents only half of the Jenkins GitHub integration puzzle. The other half is to have GitHub trigger a Jenkins to build when a developer pushes new code to the repository. The whole idea behind Jenkins CI/CD pipeline is to be constantly compiling code and running test suites to ensure software development constantly moves forward. If a build is broken or a test fails, it is a job of the CI/CD server to inform the team so the setback can be adjusted immediately. This means Jenkins must be notified every time a Git commit is pushed to the GitHub server. The tight integration between the tools is achieved through a Jenkins GitHub webhook. For the GitHub integration to succeed with the webhook, an API token was generated in the Jenkins and then shared as part of the webhook configurations in GitHub by using the credential keys. In order to increase the lifetime of our applications, we use SonarQube as part of the build process to ensure a high quality of code and remove bugs that can be found during static analysis. SonarQube is a code quality assurance tool that collects and analyzes source code and provides reports for the code quality for the project. It combines static and dynamic analysis tools and enables qualities to be measured continually over time. The benefits of using SonarQube are firstly increased sustainability by reducing complexity, possible vulnerabilities, and the code duplications. It secondly increased the productivity by reducing the scale, cost of maintenance, and risk of application. As a consequence, it removes the need to spend more time changing the code. After the code is scanned and no errors are found, Jenkins will generate a build document and artifacts that might consist of the project source codes, dependencies, binaries, or resources. Then these artifacts will be uploaded to the S3 bucket and deployed through the AWS CloudFront. And these artifacts will be presented as the website for the users to interact with. Let's move on to the next page. When it comes to the back-end CI/CD, the first part of the process are pretty similar to the front-end CI/CD. When the configurations are done, the webhook will trigger Jenkins to pull the code from GitHub to Dockerize the app and build into the image. Before that, SonarQube scanner will be triggered again to generate a report. When there is no errors, the image will be built and passed to Trivy. Trivy is another tool to ensure the production goes right, and is a simple and comprehensive vulnerability scanner for containers and other artifacts. Vulnerability is a glitch, flaws, or weakness present in the software or in operating system, which could cause a lot of security issues and further causing loss to the product users and the owner. When the severity level returns medium to critical, Trivy will stop passing images to the next step. Otherwise, the image will be pushed to ECR, which is Amazon Elastic Container Registry. ECR is a fully managed Docker container registry that makes it easy to store, manage, and deploy Docker containers images. We use Amazon Fargate to host the container images. The benefits of using Fargate is that there's no cluster to manage, not having to create EC2, as well as not having to refresh AMI. And the scaling is seamless and you can pay for what you use. Moreover, Fargate is integrated with the AWS ecosystem and it is highly available. Let's move on to the next page, please. In the monitoring stage, we configure Grafana to observe the latency, traffic, errors, and the saturation according to four golden signals principles. Let's move on to the next page. At the end of this presentation, I would like to thank our team members who participate and contribute to this project. And I would like to represent our team to thank all our tutors for supporting us. And finally, thank you for attending and listening our presentation. If you have any questions, please feel free to approach us and ask our team. Thank you.
Thank you, Lawrence. That's all for our project. Thank you, everyone.